This is number 7 in your Unit 2 study guide, and again, we're asked to find all zeros, both real and complex. We wouldn't know how to factor this, so we have to start off with our possible rational zeros, so listing the p over q. Because our leading coefficient is 1, I know that q is positive or negative 1, so really we can just look at p, which comes from the factors of that negative 10 there. So we know that it's positive or negative 1, 2, 5, and 10. And this is where you would have to start testing these out. If you had a graphing calculator, this would be a great time to go through and see which ones work, just to kind of narrow things down. If you didn't have a graphing calculator, you could go through and try it either with synthetic division or by plugging these numbers back into the polynomial and finding what works. So I happen to know what does work, so I'm going to go ahead and start with one of them that works, which was 2. So using synthetic division, we have 1, 1, 1, negative 9, and negative 10. And we don't need to do any zero placeholders, so we're just going to go ahead and use synthetic division. 7, 14, 5, 10, and we get that remainder of 0. So far that means that we have the polynomial x minus 2, and then here we have the constant, here's the x squared, and here's the x cubed. So far it's factored to be a cubic over here, which sometimes we may get lucky and we may see that that factors and you can just find two other rational zeros that way. But in this case, I don't know how to factor that, so I'm actually going to have to keep going with synthetic division. But I can divide it into this new polynomial because now I want to factor this into something else. So I'm going to use the 1, 3, 7, and 5. Now, 2 could be another 0. It can have a multiplicity bigger than 1, so you could always try that again. But I actually found out another one that works is negative 1. So using synthetic division, we'll bring the 1 down. And we get a 5 there, so this is negative 5, which means we have a remainder of 0. So that means we are now at x minus 2, x plus 1, and then this is my constant, my x, and my x squared. So this factors to be x squared plus 2x plus 5, which this is good news. We want it to get to a quadratic so that we can either factor it further or use the quadratic formula. And unfortunately, this doesn't factor, so we are going to have to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times 1 or 2. So here we get negative 2 plus or minus that discriminant. We do 4 minus 20, so it's the square root of negative 16 all over 2. So this is negative 2 plus or minus 4i over 2. And we want to write that in the form a plus bi, so we do the negative 2 over 2 and get negative 1, and then the 4i over 2 is plus or minus 2i. So it turns out if we have to list out our zeros, we have 2, negative 1, and negative 1 plus or minus 2i. Hopefully we needed 4 zeros. Let's double check. The degree of the original polynomial was 4, so that's good. They each happen to have a multiplicity of 1, so they asked for the multiplicity. They all have a multiplicity of 1. And then it did ask for the final factored form. So to factor it out, we're just listing it out as x minus 2 times x minus a negative 1, which is plus 1, and then x minus each of these. So I'm putting those in parentheses just so that I remember that I'm subtracting the entire thing. So negative 1 minus 2i there. And then we could simplify that. So we would have x minus 2, x plus 1, and then here x plus 1 minus 2i, and then x plus 1 plus 2i. And that would be our final factored form for that entire polynomial.